Assalamu alaikum. This is Sir Talha and welcome to my channel. Please subscribe my channel to support us and watch all these videos I make for you guys so that you can prepare good for Ecat. These all are the videos you can access through different playlists like this by going on the playlists, and you can open playlist for every different chapter like vector chapter 9 of maths second year, integration as a different playlist, circle chapter as a different playlist. So I have made all these playlists differently: second year chemistry, first year chemistry, second year maths, first year maths. So please subscribe my channel. Now I'm starting the content. I'm talking about manufacture of the sulfuric acid, chapter number 4 P block was going on. So how the manufacturing of sulfuric acid happens. The process which is used to make sulfuric acid commercially is called contact process. So what we do in this process, we first do oxidation of the iron pyrite, okay? Or this is also called elemental sulfur. Then from this we form sulfur dioxide. Oxidation, from the oxidation of iron pyrite we form sulfur dioxide. Then on further oxidation of this, okay, we are doing further oxidation of sulfur dioxide to obtain sulfur trioxide. Sulfur trioxide, what does sulfur trioxide means and what does sulfur dioxide means? So this is the formula for sulfur trioxide. Means there are 3 O's, and sulfur dioxide is there are 2 oxygen molecules. So I am just explaining you the description of this whole process, which is not so important for aptitude test, but I'm just telling you for the knowledge. When the contact process starts, iron pyrite is burned in the burner. First is the burner, then it forms sulfur dioxide, SO2. Then SO2 is passed through a special filters and then washed, and then it is dried. And after that, it's sent to contact chamber. Okay. Then the impurities are removed in that contact chamber. I am writing here. Impurities are removed, that's important, using vanadium pentoxide. This is the catalyst we are using to remove the impurities. Okay. Then further oxidation of SO2 produces SO3 sulfur trioxide, which is then absorbed in sulfuric acid to form oleum. Oleum is obtained at the end. Okay, what is oleum name in chemistry? Pyrosulfuric acid. Pyrosulfuric acid. Okay. Then at last, sulfuric acid is obtained. So this was the preparation of the sulfuric acid. Now we are doing its uses. Where sulfuric acid is being used, sulfuric acid is basically called the king of compounds. Okay, it's used in many of the substance for the manufacturing of dyes, okay, detergents, explosives, bombs, in medicines, paints, pigments, etc., and many others. Okay. Ether, ethylene, alum, leather tanning, fertilizers, artificial fibers, fibers like rayon, plastics, and all the production of for hydrochloric acid and hydrofluorine, HF and HCl. HF and HCl also being made from the sulfuric acid, and for the pickling of steel also. Pickling of steel. These all are the uses of sulfuric acid, etc. Many others. Now, the next preparation is about manufacturing of chlorine. How chlorine is being manufactured in the industry by Nelson process. Okay, chlorine is produced, manufactured by Nelson process, or also called Kastner-Kellner process. Kastner, Kastner-Kellner process. Okay, what we do in this electrolysis of sodium chloride, NaCl. Okay, what is cathode, what is anode? In electrolysis, always there will be one anode and one cathode. So what is cathode and anode? Cathode is U-tube steel tank, and anode is graphite. Okay, just I am telling you now the description. When the in Nelson process, we use aqueous solution of NaCl, sodium chloride. Then it is then electrolyzed, and then it produces chlorine gas at anode. Chlorine gas is manufactured at anode. Chlorine gas, Cl2. Okay. Then what happens? The sodium formed at cathode. Here at cathode, sodium is formed, Na. Then it reacts with water. The sodium formed at cathode reacts with water and forms sodium hydroxide. It then forms, when react with water, sodium forms NaOH, sodium hydroxide. Okay. When sodium hydroxide and also hydrogen gas is obtained, and sodium is reacting with water, sodium hydroxide and hydrogen gas obtained, then both of these products are separated and being used where we want to use. And the chlorine gas, what we have to manufacture is chlorine gas that we have obtained already, okay, at the anode. So this was the manufacturing of chlorine. Now talking about the uses, okay, what are the uses? Used to manufacture synthetic fiber. I'm only telling you the uses which are written in your books. Bleaching powder, HCl, PVC, DDT, CCl fluor, CHCl3, all these are manufactured by using chlorine. Then after this bleaching powder, bleaching agent is being manufactured that is used for cotton, linen, wood pulp, rayon, etc. Chlorine is also used for sterilization of drinking water. That's important. Sterilization to clean drinking water. Okay. Also used for warfare gases. Warfare gases means like phosgene. You have to remember this MCQs. It has been in the past papers. So the chlorine is used in the manufacture of warfare gases like phosgene, chloropicrene. I'm writing all these gases. I'm writing with a different color. Chloropicrene. Okay. And mustard gas. Phosgene is important. You have to remember this name. So now talking about the allotropy. What is allotropy? Basically, allotropy is the existence of an element in more than one form is called allotropy. Means a mixture of the two. All right, in more than one form or mixture of the two in more than one form. It's called allotropy. Okay. Existence of an element in more than one form is known as allotropy. There are different forms. Okay. Means in which element possesses similar chemical properties but different physical properties. Okay, chemical properties are similar but physical properties are not. And why is that so? Why physical properties are not similar? Because due to the arrangement of atoms in lattice, the atoms in the lattice structure get changes. So that's why physical properties not remain same. So I'm writing the allotropes of carbon. Carbon basically exists in two allotropic forms. First is crystalline. Okay. In crystalline, uh, diamond exists, graphite, and only two are okay. Two will be okay. And the other form are amorphous. Okay. Amorphous form is charcoal, lamp black, coke, lamp black, coke, gas carbon. Okay, these all are the amorphous form. Now, talking about the diamond, what is diamond? Diamond is the hardest natural substance. Hardest natural, and it's natural. We are not making it means by doing different processes, but it is existing natural and hardest substance known. Okay. Different properties. Density is 3.51 grams, mass in grams, and volume in centimeter cube. But the thing is, it is a bad conductor of heat and electricity. Okay. Its melting point is 3500 degrees centigrade. Melting point. Okay. Melts at 3500. And what more? I'm telling you its uses. Important uses of diamond. It's used because of its hardness. It's used for cutting. Okay. Cutting glass, drilling rocks, cutting big rocks, okay, those in the mountains, and many other purposes. Okay, now I'm telling you the comparison of the diamond and graphite. Diamond, graphite. Diamond occurs naturally in free state, okay? Free state. Naturally in free state of the diamond, okay? But it can also manufactured artificially, graphite. We cannot make diamond artificially. Hardest substance known, soft and greasy. More density, 3.5 density. Its density is 2.3 grams per cm cube. Non-conductor. Non-conductor, good conductor. Graphite is a good conductor of heat and electricity. And while diamond is transparent, and the graphite is black in color. Okay. While diamond is insoluble, okay, in solvents. And the crystals of diamond are octahedral, and the crystals of graphite are hexagonal. Hexagonal and octagonal. Octagonal means 8 sides. Hexagonal means 6 sides. Now the structure of diamond is it's being sp3 hybridized diamonds, okay, tetrahedrally arranged because of sp3 hybridization. I am talking about the structure of diamond, okay. And all these I've talked before. The diamond is very hard, high melting points, boiling points, do not conduct electricity. While for the graphite, it's hexagonal layered structure and sp2 hybridized. Graphite are sp2 hybridized, okay. I think these are enough for this. Coal. These are the crystalline forms. The forms we have discussed, diamond and graphite, are the crystalline forms, allotropes of carbon. Now, for the amorphous form, the first is coal. Okay. Coal is the amorphous form of carbon found as a mineral. It is a mineral extracted from the ores. Okay. जमीन के अंदर से निकलता है. There are also allotropes of sulfur being discussed in your book. So alpha sulfur, beta sulfur, gamma sulfur, and omega sulfur. I'm talking about, it's not important. So I'm talking about boric acid. Okay. So what is boric acid? It's very soft and milky white crystalline solid. Solid होता है, crystalline, color white or very soft, insoluble in cold water. These are the characteristics. But soluble in hot water. But soluble in hot water. Okay. You don't have to remember its preparation. I'm only telling you its uses. Preparation equation means no need to remember this. Boric acid is being used as mild antiseptic. Okay. Food preservative. Food not get means बासी नहीं होता है food preservative. Eye wash, medical purpose, pottery, glazes, pottery, glass, all are these are the uses. Now second important is called substance is called borax. What is borax? Tetra borate, decahydrate, tetraborate, decahydrate. And its chemical formula is NaB4O7 dot 10H2O. Whenever there is a word written hydrate, then it's mean H2 is being added. It is also known as tinkle or suhaga. Tinkle, TINCL, tinkle or suhaga. Okay. And its characteristics are it is a colorless, sparingly soluble, slightly soluble means sparingly means slightly, and crystalline solid. Okay, this is the characteristics of borax. The further preparation is not so important. The preparation equation talking about the uses, where borax is used for the manufacturing of optical glasses, okay, for tiles, pottery glaze, and also for soldering and welding. Soldering and welding purpose, okay? It's also being used for joining the things. The next compound is alum. What is alum? Alum is also known as pitkari. Pitkari, okay? It is basically prepared during the preparation of aluminium. We have already studied, okay? Is a series, basically is a series of double sulfates and is a combination of water of crystallization molecules around containing 24 molecules. You have to remember these formulas I am writing here. If aluminum is present, if Al is present or aluminum, then the name of monovalent element is used. Monovalent element, okay? The names are potash alum, ammonium alum, okay? Potash alum and ammonium alum when Al is not present. Sorry, when Al is present. The formula is for potash alum K2SO4 potassium sulfate dot Al2SO4 3 dot 24 H2O. Look, 24 water crystallization are present. This is the formula for potash alum. Now I'm writing for ammonium alum, NH4 2SO4, okay, dot Al2SO4 3 dot 24 H2O. Same after the first thing. This is the difference only. K2SO4 and NH4SO4. Al2SO4 is known as alum and 24H2O is known as water of crystallization. So the things after the first formula are the same for both. Now I'm talking about without Al. If Al is not present, my writing is not so bad. Chromium alum. Chromium alum when the NH Al is not present. So it's like NH4 sodium hydroxide SO4 Cr2, this chromium SO4, its valency is 3, so 3.24H2O. No Al present, okay? No Al in all, in whole the formula. Ferric alum. NH4 2SO4. This will be changed. This is ferric iron 24H2O. Okay. So this formula is changed for, this is for chromium, this is for ferric. Okay. You have to remember these formula with the names. This is important. Now preparation for the alum is simpler. From K2SO4 L2SO4 on the crystallization we produce alum. Okay, I'm telling about the uses. Aluminium, like the aluminium, alum is used in making cloth water wash. Okay, for purification of water. For tanning leather. For sizing paper. For fire extinguisher. For dyeing clothes. And that's it, etc. Many other uses. These are enough. So for tanning leather, sizing paper, fire extinguisher, dyeing clothes, making cloth water wash means serve cloth water. Okay. Two other substance remaining. Lead pigments. Lead basically forms different types of pigments that are used in paints. So there are different colors: white lead pigment, red lead pigment, chrome yellow, chrome red, Turner yellow. There are the different types of lead pigments for the different equations from these are being manufactured. So it's not that important because equations are not so important. Hydrogen sulfide. Okay. Hydrogen sulfide is also known as gutter gas. Okay. Basically, because of gas, it's colorless, toxic. Toxic means reactive, unpleasant smelling. It is unpleasant smelling, soluble in water. It is also called acidic gas. Acidic gas. Okay. So simple. It's this is very simple preparation. Hydrogen with sulfur, hydrogen sulfide. Okay. And talking about its uses, being used as a reagent. Okay. For identifying cations and for analyzing metal and their ores. This is very difficult to analyze the ores of metals. So hydrogen sulfide is being used for this process. And this is the end of chapter number 4 of second year chemistry, P block elements. There are also one lecture before this lecture. So I've completed this whole chapter in 2 lectures. So thanks for watching. Please share and subscribe. Thank you.